Hey guys, today we're looking at section 4.5, which is going to go over some analytical problems for particle motion. So let's go ahead and get started. A particle moves along the x-axis so that a time t, its position is given by this equation right here. So at time t equals 0, is the particle moving to the right or to the left? Explain your answer. So we know that it's moving to the right if the velocity is positive, and we know it's moving to the left if the velocity is negative. So let's figure out what our velocity equation is, plug in 0, and see if it's positive or negative. So to find the velocity, we're going to take the derivative. So if I have t cubed, that derivative is 3t squared. Minus, if I have 6t squared, that 2 is going to come down and it's going to be a negative 12t. Then I'm going to have plus 9, and the derivative of 11 is just 0, so that goes away. So if I'm looking specifically for x prime of 0, I'm going to have 3 times 0 squared minus 12 times 0 plus 9, which gives me 9. So I can say, I'm going to type it out for you guys. The particle is moving to the right at the time t is equal to 0 because the velocity at t equals 0 is positive. So there is number 1, part A. Let's look at part B. So at t equals 1, is the velocity of the particle increasing or decreasing? Explain your answer. So if we're looking for when the velocity is increasing or decreasing, it's going to be increasing when the acceleration is positive and decreasing when our acceleration is negative. So from part A, our velocity, or our derivative for x of t, was 3t squared minus 12t plus 9. So let's find the derivative of our velocity, which would be our acceleration. So that 2 is going to come down, and it's going to be 6t minus 12. And so at t equals 1, so I'm looking for the acceleration at 1. So 6 times 1 minus 12 gives me 6 minus 12, or a negative 6. So I can say that because our acceleration is negative, our velocity is decreasing. So I'm going to say the velocity is decreasing at time t equals 1 because the acceleration is negative at t equals 1. So there is part B. Let's look at part C. So part C says find all the values of t for which the particle is moving to the left. So our particle is moving to the left when our velocity is negative. So what I'm going to do is I'm going to find when my velocity is equal to 0, and then I'm going to plug in some numbers on either side of those to figure out when my velocity is negative. So my velocity equation from part A, the velocity is equal to 3t squared minus 12t plus 9. So I'm going to figure out when 3t squared minus 12t plus 9 is equal to 0. So the first thing I can do is divide everything by 3. So t squared minus 4t plus 3 is equal to 0. And then I can factor it. So if I'm looking at this, I need something that multiplies to give me 3 and adds to give me negative 4. So that's going to be t minus 3 and t minus 1. So that means t is equal to 3 and t is equal to 1. It gives me a velocity of 0. So I'm going to make a number line over here, and I'm going to plug in that point of 1 and that point of 3. So now what I need to do is pick some points that aren't 1 or 3, that fall into my 3 different chunks of my graph that I'm looking at. So I need to pick something less than 1, so let's do 0. I need to pick something between 1 and 3, so let's do 2, and something greater than 3, so let's do 4. So what I'm going to do here is I'm going to plug those in to my velocity to see if it's positive or negative, and that'll tell me if it's moving to the left or moving to the right. So when I plug 0 in, and we'll use this equation right here, when I plug 0 in, I end up with 3 times 0 squared minus 12 times 0 plus 9. So I end up with 9, which is a positive number. When I plug 2 in, I get 3 times 2 squared minus 12 times 2 plus 9. So 2 squared is 4 times 3 is 12. Minus 12 times 2 is 24 plus 9. So 12 minus 24 is a negative 12 plus 9, which gives me a negative 3. So that is a negative at 2. And let's see what happens when we plug in 4. So 3 times 4 squared minus 12 times 4 plus 9. So 3 times 16 minus 48 plus 9. Well, when I look at that, 3 times 16 gives me a 48 minus a 48 plus 9. So 48 minus 48 plus 9. Those are going to cancel out and I end up with 9, which is positive. So remember, if I'm looking for where it's moving to the left, that's going to be when it is negative. So that's going to be this right here. So I can say that t is moving to the left when it's between 1 and 3. So I'm going to type that out for us. I'm going to say the particle is moving to the left on the interval 1 to 3 because the velocity is negative on that interval. So that's kind of our explanation for why it's moving to the left. So it's going to be moving to the right up until 1, then it's going to turn around and move to the left until 3, and then turn back around and move to the right. And we actually are going to use this to help us with our next part, part D. So part D says find the total distance traveled by the particle over the time interval 0 to 5. So if I were to kind of take that number line that we were looking at, and I'm going to draw it up here again. So we had from 1 to 3, it was moving to the left. Then over here it was moving to the right, and over here it was moving to the right. So to find the total distance, we're going to have to figure out how far to the right did it move, how far to the left did it move, and then how far to the right did it move. And we're only looking on our interval from 0 to 5. So what I'm going to do is I'm going to make a little t-chart over here. And I'm going to put all of those numbers on my chart. So I'm going to have 0, 1, 3, and 5. Because we're starting at 0, we change directions at 1, we change directions at 3, and we're ending at 5. So those are my t values. And then from here, if I'm trying to find the total distance, I'm going to find x of t. So I'm going to find the position at 0, position at 1, position at 3, and position at 5. So at 0, I'm looking at 0 cubed minus 6 times 0 squared plus 9 times 0 plus 11. So we're starting at the position 11. Then at 1, I'm going to have 1 cubed minus 6 times 1 squared plus 9 times 1 plus 11. So 1 cubed is 1, minus 6 would be a negative 5. Then plus 9 would be 4, and plus 11 would get me 15. So it moved from 11 to 15. So that means that it went to the right 4 units here. So now I'm going to find my position at 3. So 3 cubed minus 6 times 3 squared plus 9 times 3 plus 11. So 3 cubed is 27 minus 6 times 9 plus 9 times 3 is 27 plus 11. And so when you add and subtract all of those, you end up with 11. So from our time t is equal to 1 to 3 seconds, it went from 15 to 11, so it went to the left 4. And then we need to find from 3 to 5. So I'm going to look at 5 cubed minus 6 times 5 squared plus 9 times 5 plus 11. And when I do that one, you can plug it into your calculator or do it all by hand, and you should end up with 31, which means that it went to the right 20. So to find my total distance, I'm going to add up that 4, and that 20. So 4 plus 20, and that's going to give me 28. So our total distance is 28 units. So now part E is going to talk about our displacement. So remember, displacement is just how far away is it from where it started. So remember, our position at 0 is 11, and then we're going to find our position at 5, which on our previous slide we said that at 5 it was at 31. So I need to find the difference between 11 and 31. So our difference between those is 20 units. So our displacement is just 20 units, whereas our total distance was 28. All right, the next thing says, is the particle's speed increasing or decreasing at t equals 4? So remember, our speed has to deal with our signs for our velocity and our acceleration. So we know that our velocity equation from part A, so v of t, is equal to 3t squared minus 12t plus 9. And I know that my acceleration from part B, where we had to find out if the velocity was increasing or decreasing, my acceleration is 6t minus 12. So what I'm going to do is I'm going to plug in 4 and see if I have the same sign or opposite sign. So the velocity at 4 is going to be 3 times 4 squared minus 12 times 4 plus 9. So 3 times 16 minus 12 times 4 is 48 plus 9. So 3 times 16 is 48 minus 48 plus 9. So we end up with 9, which is a positive number. And let's find our acceleration at 4. So 6 times 4 minus 12. Well, 6 times 4 is 24 minus 12 gives us 12, which is also a positive number. So since they are both positive, they have the same sign, I can say that the speed is increasing. So when I write out my answer, I'm going to say the speed of the particle is increasing at t equals 4 because the velocity and acceleration have the same signs. So there is our explanation and our answer there. And I believe we have one more that we're going to look at. It says, when does the particle whose position is given by the equation here change directions? So remember, it changes directions when our velocity is equal to 0. So let's find what our velocity is, set it equal to 0, and see when it changes directions. So I'm going to find the velocity of t by taking the derivative. So that's going to be 3t squared minus 6t plus 12. So 3t squared minus 6t plus 12 has to equal 0. I can divide everything by 3 to make my factoring a little bit easier. So t squared minus 2t plus 4 equals 0. And when we're looking at trying to factor this, I can do 2 times 2 or 4 times 1. So it looks like it's not going to factor for us. So instead, we're going to have to do our quadratic formula. So x is equal to negative b, so 2 plus or minus the square root of b squared, which would be 4, minus 4 times a times c, so 4 times 4 is 16, all over 2 times a, which would be 1, so I'm just going to say 2. So I have x is equal to 2 plus or minus the square root. Well, 4 minus 16 is a negative 12 over 2. And if you're looking right here, I can't really take the square root of a negative number. So what that means is that this never changes directions. Our particle is not ever going to change directions. So that's what I'm going to type down here. And I'm going to say the particle does not change directions because the velocity is never equal to 0. All right, so that is it for this video. You do have a Go formative assignment that you need to work on, so make sure you get started on that. And then if you have any questions, please email me, come to my tutoring times, or you can ask some questions at our next class period. So go ahead and get started on that Go formative, and you guys have a good day.